Let's write a function called rotateString_left. So write the function rotateString_left that takes a string s and a non-negative integer k and returns the string s rotated k places to the left. So below I've written down some examples of what this actually means. So let's say we want to identify the string s as equaling Shrek. So I'll even put that in a little string. So s is going to equal the string Shrek. And I put a bunch of different k's down here, so 0 to 5. And below I denoted what the output would be. So if we rotate Shrek 0 times, it'll just be Shrek. If we rotate it once, then we basically take that s from the beginning and we put it at the end. One more time, so if we rotate it twice, then not only would we put that s at the end, but we'd put the h at the end as well, and so on with the r, and then the e. And then after 5 rotations, we'd be all the way back to Shrek. So after actually understanding the problem, I like to, I have the examples now, and I want to now understand a pattern between these different outputs. So from 0 to 1, we basically see that this is just different substrings from Shrek, but like concatenated together. So specifically, we have the HREK from the end of Shrek, and we have the S from the beginning. And so if we actually want to slice this in Python, very specifically, it would be s from 1 to the end, so 1 until len of s, and then that's added to s from 0, from the beginning, until 1. In Python, I actually didn't put the 0 there because you don't need that to be there. It'll just default to 0 if you don't put anything in the beginning. And that actually also is the case for this, so I actually don't need that len of s there. So here, we have we have s from 1 to the end plus s from the beginning to 1. Let's see about 2. So if we split this up like we did up here, we see that the REK is from the end, we see that the SH is from the beginning, and if we slice it just like we did above, we can get s from 2 to the end right here, and then we can add that to s from the beginning until 2. And just to prove that to you, up here we have 0, 1, 2, 3, 4, right? These are the different indices. And so if we do 2 to the end, that'll grab this 2 and go all the way to the end, so REK right there. And then 0 to 2 will be 0 to 2, but non-inclusive of 2. So really, it'll just include 0 and 1, SH, as we see here. If we keep going, we can actually continue this pattern on, and it'll still work. So we can go S from 3 to the end, plus S from the beginning to 3, and then I'm even just going to copy and paste this because it is the same exact thing. So from 0 to 4, and so on. Down here, I'm sorry, if we want to do 5, so if we continue this on, let's see if this works. So S from 5 to the end, that is actually going to be, so 5 to the end is going to be 5 to 5. So that's actually going to be out of bounds, but slicing out of bounds doesn't return a crash. So this is just going to return the empty string, as we see like right there. Perfect. And then S from 0 to 5, that also works. So S from 0 to 5, that's just going to be Shrek. So we see here that we have Shrek. Now let's do 6. So 6, we rotate once, we get HREKS, then we get REKSH, so on and so forth. And then to rotate, and then at 5, we have Shrek. If we want to rotate left one more time, we have to do HREK, and then we pull that S from the beginning and put it at the end. If you notice, this is actually the same exact thing as this, HREKS, HREKS. So how can we basically, so if we want to continue on with this pattern, I'm actually going to change this back so you can see the pattern, from 5 to the end. Over here, if we continued that on, so S from the beginning to 6, I'm sorry, this doesn't work anymore. Because S from 0 to 6, that's the entire string. So this is saying that it should be Shrek, but it shouldn't. Instead, it should be HREKS, which is the same as 1. So how can we get from 6 to 1? You can mod by 5, right? So if I do 6 mod 5, 6 mod 5, that is going to be 1, and this calculates to 1. But where did I pull 5 out of, right? Like, how did I say that, like, that's pretty random, right? It's because the length of Shrek is 5. Not Shrek. Len of S. And then over here, len of S. And that would work, right? Even if we go to 7. Sorry, up here. So 7. Instead of 6, we put 7. Instead of 6, we put 7. And then, again, we want to pull this H and throw it over here in the beginning. So REKSH, this 7 mod len of S, so 7 mod 2, that's 2. And REKSH is the same as rotating by 2. So that works perfectly. So this is basically our answer. But when we put it into the function rotateString left, we can't just have 6, because if we run this and we test it with test rotateString left, capital left, and we return that, it fails, right? And that's because this isn't general. This is very specific to calling this function with the k of 6. So to make it more general, we just put k in there. Because again, this 7 is from the k, 6 is from the k, 5, 4, 3, 2, 1, all the way. It's the same exact thing because we just found a general solution to this problem. So if I run this again and I test it, we pass that function. So that's how you solve rotateString left. Basically what we did was we read the problem, and then we wrote down as many solutions as we could think of, and we kept going because we wanted to, this solution worked for 5, but we needed this mod len of S for 6. So I tested another case just to make sure that that worked, and I saw that it didn't, so I had to add this other part. So we first read the problem, then we wrote down a bunch of examples, as many as we can think of, and then we found a general solution to this problem by trying to identify patterns. And so I recommend that you do that for a bunch of different things, a bunch of other problems. And so now we're actually going to try to use that for rotateString right. So it's basically the same problem, but it's rotating the other way. So again, I wrote some examples down here, and let's look at the pattern here to help us understand how we can solve this problem. So if we start with donkey, then we move this y to the beginning. Instead of moving the d from the beginning to the end, we put the y from the end to the beginning. And then if we rotate once more, we take the e and put that at the beginning, and so on with the k, and so forth, right? So again, it's the same, very, very similar problem. So like we did with the last problem, let's try to actually slice this and see what we get. So if I want to slice this, then I can go from s from the basically end of the word. So this is going to be 0, 1, 2, 3, 4, 5. So the length is 6, but if I'm slicing y, it's going to be from 5 to the end, and then it's going to be from 0 until 5 for the second part. So s of 0 to 5. So in the last time, it was really, really helpful because we could just say, for 1, this 1 was right here, right? So we could just put k right in here, and then that would be the answer. But over here, this is not the case. We have 5 versus 1. So in order to actually make this work, let's put len of s minus 1. So if len of s is 6, then we get 6 minus 1, which is 5. And we can do the same thing here. So len of s minus 1. And then if we copy and paste that down here, then again, we can kind of get the same exact answer, right? So it'll be 0, it'll be len of s minus 1 to the end, and then 0 to len of s minus 1. So what we can do here, let's actually try to use rotateString left. And if we rotateString left with, instead of k, we do len of s minus k, then that should be the same answer, right? Because over here, let me actually change these like we did before. Because this, I'm actually going to copy this and put it up here. So these two things are the same answer, except instead of this being k, it's now len of s minus k. And then this is the same answer as the one down here, except instead of it being 2, it's len of s minus 2. So we can just put len of s minus k in place of k for rotateString left, and that should work. So if I call test, instead of rotateString left, I call it on test rotateString right, it works. Because again, this is the same exact pattern as we saw up here except instead of this just being k, it's now len of s minus k. And so we don't even need to worry about the overflow in like this 13 case because it's handled in rotateString left. But this, we can even take this a step further. So instead of len of s minus k, let's see if we can make that a little simpler. So over here, len of s minus k is 5, right? So I can go s from 5 until the end, and then add that to s from 0 to 5. And this 0, I just put that there from force of habit, but really we could just take that away, right? But we talked about a different type of indexing in class. We talked about negative indexing. So if we have donkey, then this last character is -1. And then the second to last character, this e, is at index -2, and -3, -4, and so on. So what if we used a negative value here instead of the 5? If 5 is the last character, then the negative index for that 5 is a -1. And same thing here. It's the same exact thing for 2. So instead of going from s from len of s minus 2, we can just do s from -2 to the end plus s from the beginning until -2. So instead of doing len of s minus k, we can just do -k, and when we run this, it works.